Alright, so this is like my third time recording. I hate doing this stuff. I really do. For the ADD kids, you're just going to have, I don't know what to tell you. I don't take your drugs. I don't know what to say. I had several people unsubscribe, and I get it. I'm not good at this stuff. I'm not an entertainer, you know. I'm not. I can be funny. I can be funny. But when you're talking about damn general relativity, it's hard to be funny. I'm going to take my time in this video. I'm not going to get in a hurry. Wow, I already want to just pause for a second, but I can't pause. That's the problem. Is I can't pause because I'm trying to screen record and do. Maybe if I do this. Now it's recording? What the hell? Why didn't it record a second ago? God damn it. The universe is not expanding. Why is it not expanding? Because gravitational redshift can account for the cosmological redshift. There's no reason for it to expand. There's no reason for the universe to be expanding. It does not collapse. All of these things are explained in my book. But there's one thing that I think I kind of just glazed over after going back and reading it, and I kind of wish I had written an entire chapter talking about it. And that's this notion of a time-like killing field. Now, the reason that a lot of astronomers and physicists do not take gravitational redshift into account for the cosmological redshift is because of, in the static space-time, there's the existence of something called a time-like killing field, or a time-like killing vector field, I guess is the way you say it. But anyways, this idea is that it preserves geometry. That's what this does. It preserves the geometry at the endpoints. And so, like if you explain this to some expert, they would say no, because there's no accumulation of redshift along the null geodesic. And that's wrong. That's wrong. That's not what the time-like killing field does. The time-like killing field preserves the geometry, yes, across time, though. At the moment of observation, that's where the geometry is fixed. And so the emit on top. So if this is the body, like you can say these equations are essentially the same. This is the null geodesics, and this is Schwarzschild geometry. In the null geodesics, say if you're looking at a star, it would be the top, and if you're on Earth, that would be the bottom. And so an astronomer will say there's no gravitational redshift accumulation along R. In other words, along the geometry between the star and the observer. And that is absolutely true at the moment of observation. The quantity is preserved. But if you place different observers along R, you just have different observers situated. I've got a visual down here. Then you can see that it does accumulate along R. It just doesn't change over time. And so that's why they get this. So at 1 megaparsec, between the light that's coming from this star and observed from Earth here, the Earth never changes. The properties for Earth for the observer never change, but the properties for the emitter do. So at 2 megaparsecs, the emit is larger now, and that's what this accumulation along R is. It's because it accumulates more mass the further out you go. That's because, say there's dust in here. Say, just imagine there's dust or stars or whatever in between. You include those as you go out further and further. And so at the horizon, this star is now unobservable because there's so much mass that it produces a gravitational redshift that is unobservable. It's too much stretching of the light wave. And so this actually happens in any cosmology. Your cosmological model will be a layer on top of this. It doesn't make this invalid. This is general relativity, what I'm saying. And I'm actually right here. I'm 100% right. I don't know how to prove it. Like, some people just make assertions and they're wrong. But I'm right here. I'm right because this is the only way that it's possible. This makes sense. The other shit doesn't. That's why I'm right. Anyways, check out the book if you've not started listening to the book. Listen to the book. My older videos are garbage, but all of my videos are pretty terrible. But the research is pretty good. I do the best I can to explain it. Buy the book. I need you to buy the book. If you buy the book and write me a good review on Amazon, subscribe to my channel, give me a thumbs up. The universe is not expanding.